Hi there, welcome back to my channel. In this video, I'll be taking you through integration by partial fraction. In our previous lesson, we dealt with integration by substitution. Now let's look at by partial fraction. I have two problems for us to solve, and I hope after this you should understand this concept. We've done partial fractions in our high school level, so we simply apply it here. Now, when we say integration, integration is just reversing what our derivative back to its function. But sometimes our derivative looks such a way that is very difficult to reverse without further alteration, right? Looking at what I have here, you can clearly see that if I don't decompose this function into two, it will be very difficult, right? So this is what you do. The function 7x plus 3 all over x minus 1 multiplying x plus 4 should be decomposed in the form a over x minus 1 plus b over x plus 4. Once I make this decomposition, then I can go ahead to find the values of a and b. Then after, I'll bring my integral back again. So using the simple partial fraction, what do? You cross multiply, right? So this becomes a multiplying the expression x plus 4 plus b multiplying the expression x minus 1 all over the expression x minus 1 x plus 4, right? Then you know that here and here are the same, so I just take the powers. So comparing the powers, 7x plus 3 will be equal to a multiplying x plus 4 plus b multiplying x minus 1, right? So at this point, what do? You just assume value. So when x is equal to 1, we realize that my b will be 0 because here will be 0, right? And here I'll have what? I'll have 5. 1 plus 4 is 5a. Will be equal to, when here is 1, I'll have what? 10, right? Therefore, my a is equal to what? 2. Then the next thing, when x is negative 4, this will go. I'll have b. Negative 4, I'll have negative 5b, right? Is equal to, now negative 4 times 7 is negative 28 plus 3 negative 25, right? So my b is simply equal to what? 5. Therefore, my function simply becomes integral of what? My a is 2 over x minus 1 plus 5 over x plus 4, right? All the x. Is that not it? Yes. So once I have this expression, then I can easily find my integral. Okay, so here by using the fundamental laws, we just decompose it. I have integral of what? 2 over x minus 1 dx plus integral of 5 over the expression x plus 4 dx. So here, what do I get? 2 is a constant, it stands out. Integral of 1 over x minus 1 dx plus 5 stands out. Integral of 1 over x plus 4 dx as well. Now, integral of 1 over x minus 1 is the same as natural log of x minus 1. So I'll simply have 2 multiplying natural log of the expression x minus 1 plus 5 multiplying the expression natural log of x plus 4. Then we bring our plus c to it and we simply get our derivative. So this is how we apply or we solve integration by partial fraction. I have a second problem here, that is the second problem. So let's see how we solve that as well. So my problem 2, I'm going to have the expression integral of 10x plus 18 10x plus 18 all over the expression 2x plus 3 all squared, right? All squared. So to solve this expression, this is also another form of partial fraction. So I hope you've done partial fraction in your high school, so it shouldn't be a problem. It's just applying it in this manner, right? So let's see. So at this point, we do our decomposition as well. So our 10x plus 18 all over the expression 2x plus 3 all squared should be decomposed. But what's the decomposition here? Whenever you have a square of the base, what you do is you get a over 2x plus 3 plus b over the expression 2x plus 3 all squared. That is what you do. Okay, so in this form of partial fraction, this is how the decomposition becomes. So in simplifying this, you find the LCM, you have 2x plus 3 all squared as your LCM. Now this goes here, one of them, so I have a multiplying 2x plus 3. Then this goes here 1, so plus b. Alright, so comparing these two, 10x plus 18 all over the expression 2x plus 3 all squared, you can clearly see that I can equate my numerators. So a multiplying 2x by plus 3 plus b should be equal to 10x plus 18, right? So at this point, I want to find my a and b. To find a, I can, okay, for this place, it's going to be difficult. So we can simply expand this and solve it simultaneously. So I'm going to have a multiplying or 2x plus 3a plus b is equal to 10x plus 18. At this point, 3a plus b will be equal to 18 as my first equation. Then 2ax will be equal to 10x, right? 2ax will be equal to 10x. X and x will go. I'm going to have a to be equal to what? 5. Once a is 5, I'll put it here. I'm going to get 15. Then b will be equal to what? 3. As simple as that. As simple as that. So right now I have my a and b. So my integral then becomes the decomposed form a, which is what? 5 over the expression 2x plus 3 plus the expression b, which is 3 over 2x plus 3 all squared. Okay, and that is how the x. So by integration, you decompose this, you have integral 5 over 2x plus 3 dx plus another expression 3 integral of 3 over 2x plus 3 all squared, right? All dx. Now this is simple. This is like what we did. But now take notes. In this differentiation, sorry, integration, it wouldn't be as we did before. So open your eyes as to take you through this integration. So there is some little technicalities that we're going to face here. So see here. Okay, so let's see. So at this point here, I'm going to tackle this part first. So if you have 5 over this, 5 is a constant, so I'm going to have 5 out integral of 1 over 2x plus 3 dx, right? Plus here 2, 3 out integral of what? 1 over 2x plus 3 all squared dx, right? 2x plus 3 all squared. So at this point, see something here. You realize that here my x is not standing there alone, so I'll make this place a subject. Okay, so I'll make let u be equal to 2x plus 3. 2 over dx will simply be equal to what? 2. Is that not it? Replacing this dx, I'm going to have the x to be equal to 1 over 2 du, right? So I'm tackling only this part. Okay, so I'll make the subject and I'll have 5 out integral of what? 1 over u, but my dx to become 1 over 2 du, right? So therefore, my expression then goes 5 integral of 1 over 2u, right? Then I'll have my du. These two can go out and I'll have 5 out of 2 as the coefficient, 1 over u du. Remember that this is the same as natural log of u. So my first section, I'm going to have the solution to be 5 out of 2, right? Natural log of what? U, which is the same as 5 over 2. Natural log of my u was 2x plus 3. Yes, 2x plus 3. And that is for the first part. Plus, now let's tackle this section. So this section, how do we solve this as well? How do we solve this? So we can also solve that using substitution, right? Using substitution. So using substitution, I'll also make this u. When I make this u, I'm going to have what? U to the power what? I'm going to have u to be equal to 2x plus 3. As usual, the u on the x is also equal to what? 2, right? So my dx is simply equal to 1 over 2 du from this expression. So I've got my first part of the answer. I've put this in a box, right? Then the next part, now I've made my dx the subject. So at this point, I'll make my substitution. I'll have 3, my integral sign 1 over this whole thing, you represent it with what? With your u squared, then times 1 over 2 du, right? So my 1 over 2 will come out as a constant, okay? So once it comes out as a constant, I'm simply going to have 3 over 2 integral 1 over u squared. If you have this integral, how do you solve this integral? This is so simple. This is the same as 3 over 2 integral of e to the power negative 2. Is that not it? I'll just add 1. I'll have negative 1. Then I divide it by negative 1. So I'm going to have negative 3 over 2 times 1 over u. That's all.